Today is going to be fun because I'm going to be answering some of your questions that you have for me about tools. Like, how thick can the Waterjet cut? What happens if the tires go flat on the go-kart grinder? What square is my favorite? Or how come I use imperial measurements instead of metric? I'm going to answer all those and more in this video. I'm looking for a grinder, and I want to know the difference between a grinder and a sander. Here I have my go-kart grinder. From what I gather, the difference between a grinder and a sander is the surface speed of the belt. A sander I typically would use for wood because of the low belt speed. A grinder is typically used for metal and you want high belt speed. Like this one turns 103 miles per hour at a surface feet per minute of 8 to 9,000 surface feet per minute. And a sander for wood is going to turn much slower, somewhere in the 1,000 to 3,000. You can use a belt sander on metal with a low surface speed, but it's just going to take a lot longer. And vice versa. You can use a high surface speed on wood, but I'll show you what happens. So this is typically about the speed for sanding wood. You can see it sands really nice, no burn marks. But when we crank it up to grinding speed, like if you're going to do metal, watch what happens. So you can start to see it's discoloring, starting to burn it, and you can smell it in the air. Because this is a variable speed unit, I can go slow or fast. But most grinders are set at one speed. And then most wood sanders are set at one speed. So ask yourself, are you doing wood work or metal work? What happens if the tires on your go-kart grinder go flat? And I want to know the answer to that too. So 2 years ago, I took all the air out of the tires and I've been running them flat ever since. Because I wanted to see if the bead would break, would the belt track correctly, longevity of the wear on the tire. I can tell no difference between running the tires inflated or deflated. They just plain flat out work. If you'd like to see a build on this machine, I have a 4-part series on how I built it. So the answer to the question is absolutely nothing will happen if the tires run flat on the go-kart grinder. I'm in the market for a square. Which one should I get first? I would probably get the 8-inch Mega Square in cast iron if you're going to do a lot of welding. If you're more of a hobbyist, I would go with the 8-inch Mega Square in aluminum. Most likely, you're going to want to get the Monster Square to match and have a pair. And if you go with the 8-inch versions, pretty much tackle any project that you come across. But these two together are a pretty powerful combination. 2 is good, 4 is better. Cast iron for longevity, aluminum for weight. That's a good starting point. What are you spraying on your metal? I am spraying this stuff called anti-spatter spray. This is a chemical that's gonna help the spatter not to stick from MIG welding or stick welding. If you don't want those little BBs to adhere to the material, this is what I'm spraying on. This is eWeld 4. I've done a video on where I test about 60 different anti-spatters, and I came up with this one as being the best compromise between performance, cleanup, and usability. In the video where I test this, I actually did some painting over a coated material that this stuff was applied to. And in the comments, you guys said, why would you even need to worry about that? You're supposed to prep your metal perfectly and have it perfectly clean. No need to have a paintable anti-spatter spray. But what happens if you miss a spot in a little nook or cranny? I know handrails have those swirls. It's hard to get into the small spots. This, I know the paint will still stick. So that's why it should be paintable. Plasma cutters are superior. Why don't I use one? 2 reasons. The plasma cutter needs a power source and they're limited by the length of cord you can get to and reach. You need a big air compressor to run a good one. And then you have the cost of the machine. The thicker the metal you want to cut, the more expensive the machine gets. So those are some drawbacks. I can't take the plasma cutter outside. It's basically stuck here in the shop. Cutting torch, I like to use because it has no cords. I need no air compressor. It's all a self-contained unit. I can take it outside, bring it inside. I can put it on my service truck, take it anywhere I want. I can cut as thick as material as I want to. I can heat the metal and bend it with it. It's a really versatile tool. The only thing that's going to limit you is your skill set. The plasma cutter is a little easier to use right out of the box. The torch is going to require you to have some practice, but once you get your skill sets, it's the best tool for the job. Why don't I switch to using metric measurements? And the simple answer to that is all my material here in this shop is in imperial measurements, from wood to metal. So by me switching to metric, I'm just going to have to convert it back over to imperial. So yes, metric is more universal language in the world, but here in the United States, imperial is still the unit of measurement to use. And even switching to metric on my milling machines and lathes would be quite difficult due to the dials and scales that I'd have to change out. All my cars made before 1990 use imperial hardware, nuts, bolts, engine sizes, tires, wheels, gears, and that would be really tricky to convert. All the plumbing in your house, the copper tube, the water pipes, all use imperial threads. Even my clothing uses imperial, from my waist size to my shirt size. If you don't know how to use imperial, it's kind of like speaking Spanish or English. Just because people speak Spanish doesn't mean it's wrong. You just don't know how to speak the language. So therefore it sounds hard and you can't understand what they're saying.
Do you understand the words that are coming out of my mouth?
By knowing both, I'm a much more diverse person and I can go back and forth. But that's why I don't use metric measurements, because my material is not metric. How does that clamp stay in the hole in the table? This clamp has a 5/8 pin. There's no grip, there's no knurl, there's no threads. This pin fits closely in tolerance into this hole. And then what happens is when you push from the side, you bind those two pieces together and then it won't slip out. Too loose fitting hole, this would slip up. Too tight of a hole, it would have a hard time getting in. So there's about a 3 to 5 thousandths clearance to make this magic happen. What threading taps do I use? Let's take a peek and see what taps I have in my toolbox here. So I have these little organizers. I have them labeled on the top so I can see. This is my national coarse, this is my national fine, and I get all my taps off eBay or MSC. I try to buy good ones. This is a Regal. Some of these are new old stock that I get off eBay for a good price. So this one's made in Japan by YMW. This one's a GTD HW Co. USA. Oh, this is a Vermont, but you can feel the quality. They have some weight to them. Card, C-A-R-D, USA. The most common thing I have in this is they're all spiral tipped or spiral flute. And this is the real key to the success of these tools. And then when you pair it with a tool that you can drive it with, this is a power tapping gun. And then you don't have to use a hand tapper like this, you can use this. And it's all about chip removal. This pulls the chip out the back with these spiral flutes. This pushes the chip out the front, and it's all about removing that chip. And this has a flexible head so that you don't snap the tap off. Why do you still use these old hand crank milling machines? CNC machines are better. And I would agree with you, yes, CNC machines are better. They're great at doing production runs. They do take longer to set up and get programmed. They're more accurate. But for me here in the shop, I do all the opposite. I do one part, I need a fast setup, and I don't want any programming. So the hand crank machine is perfect for me. Why doesn't the slats on the Waterjet get cut? They actually do get cut, and sometimes they get cut in half. And these are a consumable. As you can see, that one just got literally cut right in half. Or they start to erode on this top surface and you replace them. So here's a section of a piece that just got sliced in half. How thick of metal can the Waterjet cut? The thickest I've ever cut is 4.5 inches thick, but I've never cut something 12, 16, 18 before, and I know this machine will probably do 12. So let's go over to the computer, program something, then come back and cut something pretty thick on the Waterjet. What CAD software do I use? I use SolidWorks because it's widely recognized. There's a lot of help, there's a lot of information. I took a 4-week course on learning SolidWorks. I can communicate with others that use SolidWorks as far as modeling and sharing models. Do I think SolidWorks is the best? No. There's other great programs out there. Is it something that I'm comfortable with using? Yes. So that's why I use it. If you're getting started and you're a student, you can get an educational copy. If you want the pro version, it'll cost you around $4,000. It's expensive, but here in my workshop, I would be lost without it, and it's worth it. So that's what I use, SolidWorks. So let's program something to cut into the Waterjet. Let's cut the letter J. It's kind of strange looking, but that's the beauty of the Waterjet. It does not care. There we go. We're going to make the letter J that's 8 inches tall out of some mild steel. And this program that Flow has gives us a theoretical cut time for the thickness of material. So let's just do some hypothetical cut times. Let's start with 1-inch thick steel. That'll take about 6 minutes. 19 minutes for 2 inches, 32 minutes for 3, 59 minutes for 4, 95 minutes for 5, and 146 minutes for 6, 182 minutes for 7, and 217 minutes for 8-inch thick steel. We better get this thing started. We're gonna have a long wait. So knowing I'm gonna cut something 8 inches thick, I'm gonna cut it out of this piece of round stock. I got it tack welded to this base plate so I can hold it down. Normally, I would position this upside down into the water and cut from the bottom down. For video sake, I kinda wanna see what it's looking like. I'm going to reverse it and we're gonna cut above the table. Noise is gonna be the only difference. I'm gonna position the work over an open spot in the table so I don't cut the slats. In order to get this to be a successful cut, I'm gonna make a couple changes. The first thing I'm gonna do is I'm going to adjust the carburetor on this machine. And what I mean by that is I'm gonna put lots of garnet through the system. This is called a metering disc. This is what I generally normally cut with. This is how much garnet can fit through that hole. And I'm gonna upsize it a lot to try to really have enough garnet to where it's still cutting at the bottom. Yes, I'm gonna be wasting quite a bit by doing this, but this is gonna ensure the cut quality is gonna be good at the bottom. So we're gonna switch to the bigger metering disc. And the next thing I'm gonna do, start the cut from the outside of the metal off the material, and then we're gonna lead in and start our J. If I were to try to pierce this, it would probably be like a 15-minute pierce. And I mean by pierce, the water jet has to dig a hole all the way through. And I don't want to sit here for 15 minutes spraying water and garnet everywhere. So we're going to start from the edge and work our way in. We'll check back in 3 hours. You're probably wondering why I'm even wasting my time trying to cut something 8 inches thick. Well, I'm not really wasting time, I'm learning. I'm learning what the machine's capable of. I'm learning what I'm going to get as a product at the end of this. I do want to see how long this actually does take to cut, and what is expected if I were to use this on a real job. You also have to remember that the machine is running unattended, which means I can be doing other things at the same time that this machine is cutting. So effectively, I'm doing 2 things at once. So even though this is a 3-hour cut time, I'm still productive while this machine is cutting. Ask yourself, what machine would you use if you needed to make this letter J in a positive and negative form? I really don't know of any. I think a wire EDM would be your closest bet, but the Waterjet just does a really good job. Looks like the cut is done, so let's move this bad boy out of the way. Predictions, I think the top of this cut is gonna look amazing. I think the bottom is gonna look like spaghetti. Wow, ow, that is amazing. Way better than I thought. Still a little chowdery. Look at that. Now that is just plain cool. The back, it looks like we got a little point there when it turns the corners. A little bit of wavering at the bottom, but that's to be expected. It looks like from the 4 to 5 inches, it cuts pretty square. So this was the stop start. I didn't quite let it go long enough for that to cut through. You know, you have to try some of these things because when a job comes along, I don't have unrealistic expectations. Well guys, that was really fun learning something new on the Waterjet today. I'm glad I was able to learn right along with you. Now if you have more tool related questions, please leave them down below in the comments. I would love to read them and maybe we can do another video just like this one. But until then, I'll see you guys on the next one.
Right.
What did he say? He said, how's his edge? He only took him down because he couldn't see the view no more. What's he on about?